Welcome to Chapter 6, the normal distribution. This chapter will be a cornerstone or a base for the remaining chapters that we're going to take in this course. So a lot of the information in this chapter are used in upcoming chapters. Unlike some of the information we've dealt with in the first 5 chapters where you just dealt with them in that chapter and then we moved on to a new topic. So this will be a foundation for upcoming topics and questions. Normal distribution, the bell curve as it's sometimes referred to, and is very important in solving business problems. They use it again for things like quality, assuming that the distribution is normal, and quality. And I mentioned in the last chapter that Poisson is used for weighting lines, but bell curves or normal distributions are used in a much broader range of topics. And we'll go through some of those as we go through the chapter. So you can use it for things like the thickness of an item, time required to complete a task, temperature, height, or in inches or centimeters. And you can use it for a very large number of potential tasks or problems. So the equivalent is you have a screwdriver. Screwdriver is a general tool. You can use it for a whole bunch of things, depending on what type of screw that you have. And your computer is a general piece of equipment. But yet you can load whatever software you need, Excel, Word, PowerPoint, various other things that you can load. And so it's a very good tool. Normal distribution is like that. And it is a continuous variable, and it is infinite to the left and to the right. So you can see that it's not they ran out of space, but it goes infinite to the left and infinite to the right. It is also symmetric. So the mean equals the mode equals the median, something we talked about in an earlier chapter. So that means that 50% of the data is below the mean or below the median, to be say it's technically correct, and 50% of the data is above the median, but all three of them are the same. So it has this, you can see why it's called the bell curve. I will mention it again. The last little point on the left here is it goes to negative infinity and it goes to positive infinity, which will come into play in various examples that we're going to do. So it's infinite to the left and infinite to the right. And it's the same amount of area. We dealt with it earlier where we had the 68%, the 95, and the 99.7 is 1, 2, and 3 standard deviations. So it's the only difference is one is a negative and one is a positive. So in this particular case, U shifts the distribution to the left or the right, but by changing the standard deviation, it increases. If you remember, we talked about how narrow the distribution looks or how flat it is. So leptokurtic and platykurtic. We talked about the shape of the curve. And again, you have different means. You have A and C are very have the same the same general shape. A and B have the same mean, but they look very different. A and C, like as I said, they have different means, but the general shape looks pretty darn close, or is intended to be. And B and C have different means and different standard deviations. So the smaller the standard deviation, the narrower and the more peaked it is. The larger the standard deviation, the wider it is. And that's important. I mentioned before, standard deviation can be used as risk in finance. It's also determined to be variability. You do not want, a lot of times, variability. Companies go out of their way to try and reduce or eliminate variability in the manufacturing process. So here is the formula. And normally, or in the past, you would have had a table on Z-scores. in all my years of teaching stats, we actually have only once had a student who actually brought this formula to class. And I'll be honest with you, I've never in my life, when I took stats at university or have taught stats, ever used this formula. We always use the tables. Well, guess what? We're not going to use the tables. For the last couple of years, we've been using Excel, and we're going to use Excel even more this term. So you're going to be well grounded in the basics of Excel for statistics. That's part of the overall goal, because industry wants that. It's not my idea. Industry has told all of the post-secondary schools in Calgary, I'm sure across Canada, students graduate and they have inadequate Excel skills. And talking to my graduate students who have graduated, yeah, they all, almost without exception, they use Excel. A lot more than you might think. So we're going to look at the standardized normal distribution. What that does is, in this case, it has a mean of 0 and a standard deviation of 1. So to find the z-score, you take the observation, which is x, you subtract the mean, and you divide it by the standard deviation. So this is where we get the left and the right. Z-scores that are positive are to the right or above the mean, and negative Z-scores are to the left. But one standard deviation to the right is the same distance as one standard deviation to the left. The only difference is the negative and the positive. So in this case, we want to find the Z-score, and we're going to use Excel. So I'll just show you the basics behind it. Get a lot of times students say, I want to see like the formulas or the process. But so in this case, you have 200 minus 100. So this will be to the right because 200 is higher than 100, divided by the standard deviation, which is 50, and you get 2. So this is 2 standard deviations. So you have to be careful. It represents the number of standard deviations, not the size of the standard deviation. 50 is the size of the standard deviation. 2 is the number of standard deviations. So in this particular case, from 100 to 200 is 2 standard deviations to the right. Now, if we have 2 standard deviations to the left, that would be 95%. So in this particular case, and we're going to use Excel for this. So half of 95% would be 47.5 from A to B. So again, here's some calculations, or just show you left and right once again. The total area under the curve is 1. And in this particular case, if you wanted to go from 0 to the 2 standard deviations, and remember, a lot of schools are still teaching using tables. We won't. In fact, as of the fall of 2020, all instructors are supposed to use Excel. And several of us have been doing it for 3 years or sometimes more. So we're using Excel to calculate this. We're not use the tables. I will not show you how to use the tables. If you want to use the tables, you will be slower. And you're on your own. I'm not going to show you what would be an outdated way. If I was asked to do work for industry, which I do on occasion, I'm not going to look it up in a table. I'm going to use Excel, and then I can share it that way with people. So we want to find the area between 2 points, between A and B. We want to translate it into Z values and use the cumulative standard normal table. And all this does is show you just a graphic, and we'll go through a lot of examples like this, and you get lots of practice with the study plans. That, what is the area here? So the 18 is the mean. Find the probability that X is less than 18.6. These are in seconds, and it has a standard deviation of 5. So you find out the area from the end I should also emphasize, you can either use it from the left, from 0, or you can use it from the middle. So you have to be careful which way you're doing it. So you, again, find the standard deviation of 0.12. If you looked it up in the table, so you've got your information. And in this particular case, of the standard deviation is 5, the z-score is 0.12, and then you can also use it for finding the area above. Now it's just showing you. It hasn't told you the value. It's focusing on calculating the z-score. We will use Excel for that, as I've said a couple times already. And then we're going to want to pay attention to the shaded area. So what you have to be careful is, do you want to find the area below 18.6 or above 18.6? So there's differences here. So the area underneath the curve is obviously 1. The area below 18.6 is 0.5478, and the area above is 1 minus 0.5478 is 0.4522. So just over 45%. So relatively speaking, 55% of the time, it'll be less than 18.6 seconds, and 45% of the time, it'll be above 18.6 seconds. And again, here's just a summary of showing you the calculations. And if you want to find what is the area between the two, you would take the 0.54, I believe it was 86, and you would subtract 0.5. That will tell you the area, this little band, again, the shaded area. If you want to find the area to the left, 17.4, it'll be exactly the same amount as the area from 18 to 18.6, which is a difference of 0.6, plus if you subtract 0.6 from 18, you get 17.4, and it'll have the same area. Remember, because it's symmetric. So the area from 17.4 to 18, which is the difference of 0.6, is the same area, but it's to the left because the area is not negative, but the z-score is, as the area from 18 to 18.6, which is also plus 0.6. And that'll come very important later on when we do things like confidence intervals in an upcoming chapter. So this is just different ways to dissect the curve, and you find the area of between 17.4 and 18. Find the area, and you get a z-score of negative 0.12. You subtract that from 0.5, and that means the area from 17.4 to 18 is 0.0478. The area below, remember, it goes infinite, but the area below the 17.4 is 0.4522. So 45.22% of the time, you will have less than 17.4 seconds. 4.78% of the time, you will have 17.4 to 18. So you can find the area underneath the curve between any 2 points that you want. All right, again, if you want to find the x value, you take the mean and you add the z-score times the standard deviation. So to convert it, in this particular case, if you have a z-score of negative 0.84 multiplied by the standard deviation, and then add that, which in this case is subtracting, because the z-score is negative, 13.8. So 20% of the values with a mean of 18 and a standard deviation of 5 are less than 13.8. So 20% of the time, the amount of time in seconds will be less than 13.8. Now, you then might consider that to be very fast. If you have an employee who can consistently produce whatever this is, or a machine, that could be considered like you'd want to find out why, so maybe you can improve your process. But only 20% of the time is it below that number, which also means that 80% of the time it's above 13.8. Here is the way that you calculate the probabilities, and the main one that we're going to use is the norm.dist. And we'll go through that in some of the specific examples. But once again, you can see if you want to set this up, there's a lot of replication in this, that you can set this up on your spreadsheet. You can print this out, and you can or look it up in your book. At the end of the chapter, you may not have noticed, at the end of the chapter, they have very nice summaries of Excel and Tableau. We're not using Tableau, but they have that. And we'll go through this. They have these shown for you in a more, well, in a textbook format. So, and we'll go through many of these when we're doing the examples that I'll do the recordings on. Not all continuous distributions are normal. We'll deal with some a little bit later in this course that are not normal. But mainly if you take stats 2, a lot of that has to do with dealing with distributions that are not normal, like chi-square and various other ones. But this is Introduction to Statistics, as you're aware. And so we're going to deal with the fundamentals. And the most common is normal. You can assume that it's normal. And there's tests for it. Remember, if the mean and the mode are the same, or if they're very close together, you can assume that the distribution is normal. So if the mean and I think I might have said mode, if the mean and the median are the same, then it's normal. If the mean and the median are very close to each other, you can assume that it's near normal, which will give you about the same results. So you can see here, and you're going to see this when we do some of the examples. All right, so in this case, the mean and the median are not quite the same. You're given all the descriptive statistics, which we took earlier, the quartiles, the 5-number summary. You see the standard deviation. You see the skewness is slightly negative, so it's left skewed. You see the kurtosis, so that means it's if it's leptokurtic because it's above 0, and things along this line. All right. So we went over computing probabilities from the normal distribution, and then especially when I show you the videos on how to go through problems from the book, we'll go through them in more detail.